Large language models are complex neural networks that are trained on vast amounts of text data to learn the underlying patterns and structures of language. These models employ a technique called unsupervised learning, where they learn from the data without explicit human guidance. Through this process, they develop an understanding of grammar, syntax, and context, enabling them to generate coherent and contextually relevant text. The pre-trained LLM stands out as a game changer, offering unparalleled capabilities to analyze and understand text with incredible speed and accuracy. Most of the time, pre-trained LLMs serve as a foundation model to support business use cases. Before delving into the definition of large in the context of large language models, it is essential to highlight the parameters that contribute to this classification. In machine learning, the term large can encompass various aspects of a model. Dataset size and model complexity are two common indicators to tell whether the model is large or not. For example, GPT-3 from OpenAI includes 175 billion parameters, while PaLM 2 from Google includes 340 billion parameters. Comparing the earlier developed BERT model, it includes 110 million parameters. On the other hand, BERT was trained on 3 terabytes of data while GPT-3 was trained on 45 terabytes of data. Small language models are compact and efficient alternatives to large language models that have gained attention in the field of natural language processing. While LLMs like GPT and PaLM have impressive capabilities, they come with high expenses for training and maintenance, as well as challenges in customization. In contrast, SLMs offer several benefits and use cases that make them a viable option in certain situations. SLMs can be fine-tuned for specific domains or tasks, resulting in better performance and understanding within those particular areas. For example, a small language model could be sufficient and cost-effective if you need a language model to generate short product descriptions for an e-commerce website. SLMs offer a cost-effective solution for enterprises leveraging AI capabilities without requesting large resources. This enables organizations to deploy language models on edge devices, further reducing costs and improving efficiency. Large language models have significantly more parameters compared to small language models. They can handle more complex language tasks and have a deeper understanding of language nuances and contextual dependencies. Large language models require more computational resources for training and inference. It is usually deployed in the cloud nowadays, but researchers are working on how we can deploy LLM on edge while keeping its amazing performance. Pre-training involves training the model on a large amount of textual data without any specific downstream tasks in mind. The idea is that the model learns general knowledge from the data it is exposed to. Fine-tuning, on the other hand, involves training the model on specific downstream tasks such as machine translation, question answering, named entity recognition, and classification. Fine-tuning LLM allows for the adaptation of the model to specific custom datasets or domains, making it more attuned to specific tasks or domains. However, LLMs also have limitations. They are limited to the textual training data they are trained with, which means they have limited knowledge of the world. For example, the trained model can be out of date if the query to the model is very time-sensitive. If the model is trained in January 2024, it may not be aware that GPT-4 Turbo is available in OpenAI, which happened in April 2024. Based on training, LLM's model may also generate discriminating dialogue or hurtful opinions. Additionally, large language models can present false information and may make biased or sexist comments due to biases present in their training data. It is important to be aware of these limitations and to critically evaluate the outputs of pre-trained models. One significant concern with large language models is the potential for inheriting and amplifying biases present in their training data. These biases can manifest in skewed representations or unfair treatment of different demographics based on race, gender, language, and cultural groups. The introduction of large language models has revolutionized the field of natural language processing and opened up a world of possibilities for various applications. These models, with their immense size and complexity, have demonstrated remarkable capabilities in understanding and generating human-like text, making them invaluable tools for researchers, developers, and everyday users alike. It has transformed the landscape of language processing, enabling more accurate, versatile, and inclusive interactions between humans and machines.